In this class, now I am going to explain you substitution method of integration. Now let us observe this example. Integral of 3x minus 4 whole cube dx. If a function is given like this, how do you evaluate whose integral? Generally, how do we think? We expand this expansion by a minus b whole cube formula. We get 4 terms, and after getting those 4 terms, then we go for integral of those 4 terms by standard formulas. You can do like that. Otherwise, to reduce that calculation burden, you better to follow this substitution. Here the substitution is 3x minus 4 equal to t. Now we have to consider this one as t. Then do the derivative on both sides with respect to x. So here minus 4 derivative is 0, x derivative 1. Left side 3 you will get, right side dt by dx. Now make dx as subject so that you will get dt by 3. You prepared dx and go back, and in the place of this write this t. Now t cube, and what about dx? dt by 3 you will get. Now write this 1 by 3 outside and evaluate this function integral. Apply the standard formula so that you will get t power 4 by 4 plus c. So in the denominator it becomes 12 plus c. At the end of the solution, in the place of t, write this value so that you will get 3x minus 4 whole to the power of 4 by 12 plus c. This is your required result for this. Okay. So doing the integral of every function by the standard formulas is somewhat difficult. So that we follow the alternative method to evaluate integrals of the function. Now let us go for one more function integral. See this. Integral of sine of 3x minus 4 dx. If a function is given like this, how do you do? Same, this one also we follow the substitution method to evaluate this function integral. So what is the substitution? See, 3x minus 4 equal to t. Now do the derivative on both sides with respect to x. This is going to be 0 and this is 1. So now 3 is equal to dt by dx. Now make dx as subject, dt by 3. Now go back, and in the place of this write t. Now sin t, in the place of dx write dt by 3. Now write 1 by 3 outside, integral of sin t minus cos t plus c. Now minus 1 by 3, in the place of t what you people have to write? 3x minus 4, cos of 3x minus 4 plus c. Okay students, now let us go for one more function. See, integral of e power ax dx or integral of e power ax plus b dx. So if the functions are given like this, how do you evaluate whose integrals? Students, see, this one here we would have to take as t. Now do the derivative on both sides with respect to x. It is going to be a, this is dt by dx. Now make dx as subject, dt by a. Now what about this? See here, go back, and in the place of this a power x write t, e power t, in the place of dx, dt by a. So 1 by a, keep it outside, integral of e power t plus c. What about t? A power x. See, e power a power x by a plus c. So this is the required integration for this given function. Okay students, see, whichever coefficient is there before x, that will come in the denominator. Okay, in the differentiation, so this a will come in the numerator. We follow the chain rule and so that we get a in the numerator place. But when you go to the integral part, so that coefficient of a will come in the denominator. Observe that point. Now, evaluate that function integral. See students, how do you evaluate this? Same, whichever is given in the index place, so that has to be taken as t. Now do the derivative on both sides with respect to x. Derivative of b is going to be 0 and x1. A is equal to dt by dx. Now make dx as subject, dt by a. Now go back and in the place of this write t, then it will become e power t dx value dt by a. Now write 1 by a outside, integral of e power t plus c, and e power t value ax plus b by a plus c. Like this you people have to evaluate integral of this function. Now let us go for integral of this function. See, 1 by a square plus x square dx. If a function is given like this, how do you evaluate whose integral? In my previous class, I kept in the place of a as 1. Then you said to me tan inverse of x, whose integral? But here a given. Whenever a is given here, how we have to evaluate whose integral? Tell me students. So here the substitution is x equal to a tan theta. X equal to a tan theta is the substitution, and see, hereafter what do? Do the derivative on both sides with respect to x. So x derivative is 1. So a into tan theta derivative. So secant square theta d theta by dx you will get. Now make a dx as subject. A secant square theta d theta will come. Now go back here and in the place of dx write this a secant square theta d theta by here a square plus x square. So a square plus x square value will become a square tan square theta. Now from the denominator take a square common and cancel with numerator. So what is left? Here a square is getting common. 1a cancel. So 1 by a integral of secant square theta by 1 plus tan square theta, which becomes secant square theta d theta will come. Both of them cancel. What is left? 1 left. 1 into d theta. 1 integral theta plus c. Now theta by a plus c you got. What is theta? See here. Transfer this a to the left side. X by a is equal to tan theta. Then your theta will become tan inverse of x by a. Okay students. Now come here, in the place of a what you have to write? 1 by a tan inverse of x by a plus c. So remember, like a standard result, whenever the function integrand is given like this, whose integral will be how much? 1 by a tan inverse of x by a plus c, where a is any real number. Okay students. Now let us go to one more rational function. See students, are you following me? See, I think you are getting when we have to apply this substitution method of integration. See, even in the case of logarithms also, suppose here see 1 by 2x plus 3 dx is given. In this case also you have to follow the substitution method of integration. See, what is the substitution? Like 2x plus 3 equal to t you have to take. So what do you get? 2x plus 3 equal to t. Now do the derivative on both sides with respect to x. It is going to be 2 and dt by dx. Now dx equal to dt by 2. Now you prepared dx. So what do you get, students? So in the place of 2x plus 3, t. Now dx value dt by 2. Now write this 1 by 2 outside, and 1 by t integral value is log mod t plus c. T value 1 by 2 log mod 2x plus 3 plus c. Okay, students? Right. Now let us see one more function. See, integral of 1 by, so here x square minus a square dx, this function is given. How do you evaluate this function? Integral. Tell me. So this one I am going to answer by partial fractions concept. See, first I would like to find partial fractions of this rational function. So first factorize the denominator. You will get x plus a and x minus a, then which is equal to a by x plus a plus b by x minus a. So denominator contains two non-repeated linear factors. In such case you have to write like that, a by x plus a plus b by x minus a. Now take cross multiplication. So 1 by x plus a and x minus a, which is equal to a of x minus a plus b of x plus a whole by x plus a x minus a. Cancel both of them and obtain a and b. To get a and b, capital A and capital B, so I would like to write x equal to a. On writing x equal to a on both sides, this is going to become 0 and this is b is equal to 1 by 2a you will get. In the same manner, put x equal to minus a on both sides. If you write x equal to minus a on both sides, this is going to become 0 and this is going to become a value minus 1 by 2a you will get. You prepared a and b values. See, observe that. Now after getting a and b values, okay, go back here and in the place of a, so minus 1 by 2a you got, na, keep it outside. 1 by x plus a dx you will get. What about b? 1 by 2a integral of 1 by x minus a dx. Now see, students, the derivative of this denominator is available in the numerator, na? In such case directly you can write log mod x plus a. What about this derivative of denominator is available in the numerator? Hence 1 by 2a log mod x minus a plus c. Okay, students. So from both of them take 1 by 2a common. If you take 1 by 2a common, so what do you get? Inside, see, if I take 1 by 2a common from both of them, so here it is looking like log a minus log b. So which becomes log a by b, log x minus a by x plus a plus c. So this is your required result for the integral of this function. Integral of 1 by x square minus a square dx is how much? 1 by 2a log mod x minus a by x plus a. Remember, like a standard result, where x is variable, a is any constant, any real number. So suppose here a square minus x square dx is given. In such case, if you follow the same procedure, you will get 1 by 2a log mod a plus x by a minus x plus c you will get. Okay, students, observe this and this. Here x square minus a square, first variable, next constant. Here first constant, next variable. So here result is 1 by 2a log mod x minus a by x plus a. Here 1 by 2a log mod a plus x by x minus a plus x by a minus x. Okay, students, remember, like a standard results which helps you while doing applications. Okay students, see, observe this function f dash of x by f of x dx. If a function is given like this, how do you find whose integral? F of x can be any function. You know, we have many more functions like inverse functions, logarithmic functions, exponential functions, trigonometric functions, inverse trigonometric functions, hyperbolic functions, inverse hyperbolic trigonometric functions, composite functions, like many more functions we have in the mathematics. F of x can be any function and whose derivative is given in the numerator. In such case, how do you evaluate whose integral? Tell me. By this substitution method of integration only, we will find this integral. So here the substitution is f of x equal to t. Now do the derivative on both sides with respect to x. F dash of x equal to dt by dx you will get. Now see, f dash of x dx, which is equal to dt. Okay students, now go to the numerator part. In the numerator part, what you would have to write? dt by t. So as you learnt one standard formula, 1 by x, integral of 1 by x dx is log x na. So as per that, this is going to be log t plus c. Now log t, t is how much? F of x plus c. Okay students, so whenever the derivative of a function is given in the numerator, then whose required result will be log mod f of x plus c. See, I am giving you a problem. See, what is the result for this? Log mod f of x plus c. So integral of 1 by x log x is given. How do you do? See, this 1 by x I am writing in the numerator, by log x dx is given. Now observe the denominator. What is there? Log x. Whose derivative is available in the numerator na? Hence whose integral will be log of log x plus c. Log of log x plus c. I hope you have understood this. Right. Now see, let us see one more example. Integral of x square minus 3x plus 4 in the numerator, 2x minus 3 dx is given. Observe, in the denominator quadratic expression is given, in the numerator whose derivative is given. Whose integral will be log mod x square minus 3x plus 4 plus c. So like that. Okay, that formula help you to evaluate this kind of function integral. Whenever the derivative of denominator is given in the numerator, in such case whose integral will be log mod denominator. See, one more example. Integral of, see, suppose function is given like this, f dash of x by root f of x dx. Now tell me students, how do you evaluate this kind of function integral? Same procedure, this denominator. So in this case, this whichever is given inside of the square root, that has to be taken t square, not t here. T square you have to take because square root is given na. So in such case you have to take t square. Now do the derivative on both sides with respect to x. F dash of x, which is equal to 2t dt by dx. Now make dx, see, transfer this dx to the left side. F dash of x dx is equal to 2t dt. Okay students, now go to the numerator. In place of this, what you people have to write? 2t dt by root f of x value t square. So square root to cancel, t you will get, tt cancel. Write to outside 1 into dt. Now 1 integral t plus c. Now 2 into t. Transfer the square to the left side so that you will get 2 into f of x plus c. This is your required result. Remember, like a standard result. Integral of f dash of x by square root of f of x dx is given. Then whose integral will be 2 into root of f of x plus c. Shall I give an example? Yes. See this. Integral of, say, you can take the previous example. So here x square minus 3x plus 4. Here whose derivative is 2x minus 3 dx. If a function is given like this, so then whose integral will be 2 into root of f of x. F of x means here. This has to be taken as f of x. Write those value, that value over here. X square minus 3x plus 4 plus c. Okay, students. Right, now I am giving you one more example for this. Integral of sec square x by root of tan x dx. If a function is given like this, whose integral will be how much? So this has to be taken as f of x. In place of f of x, compare this one and this one. In the place of f of x, tan x is there. Whose integral? Sec square x is given in the numerator. Hence, whose integral will be 2 into root of tan x plus c. Okay. Right. Next. See students. So suppose if a integrand is given like this, f of x whole power n into f dash of x dx. F of x whole power n. So beside of this, whose derivative is given. In such case, how do you evaluate this function integral? Same, by following this method of substitution, we evaluate this function integral. So here you have to consider f of x equal to t. Now do the derivative on both sides with respect to x. F dash of x equal to dt by dx. Then f dash of x dx, which is equal to dt. So come here, integral of, in place of this, so what you have to write? T. So t power n f dash of x dx is how much? Dt. Whose integral will be t power n plus 1 by n plus 1 plus c. What is t? F of x, right here. F of x whole power n plus 1 by n plus 1 plus c. Okay, students? I hope you have understood this. Remember, like a standard result, f of x whole power n plus 1 by n plus 1 plus c. Right? Now let us see one example based on this. Log of 1 plus x by 1 plus x dx. Can we able to apply previous formula for this? Yes, because log of 1 plus x derivative is how much? Log of 1 plus x derivative is 1 by 1 plus x dx. Now the derivative of this function is given beside of this. Hence, whose integral will be log of 1 plus x whole square by 2 plus c. Here nothing is given, means whole power 1 is there. That one either you can write there or here, no problem. So here in the place of n, 1 is getting, hence 1 plus 1 by 1 plus 1. So this square either you can write here or here. You know, students. So this is your required integral for this given function. Okay, students. So these are some conceptual points related to substitution method of integration. Many more conceptual points are there. So in my next class, I will continue this substitution method of integration for concept only. After completion of concept, I will concentrate on applications. Okay, students, this is one of the famous method, important method in this integration. So this class here itself I am closing. Next class I will continue this substitution method of integration. Thank you students, thank you one and all.